We'll come back to the ether topic. So we are studying the properties of the ethers in the previous videos. Now let us continue some more properties of ethers. Properties of ethers. So with sulfuric acid. Again, there are two reactions under this sulfuric acid. One is with dilute sulfuric acid. With dilute sulfuric acid, ethers give rise to two alcohol molecules. It is actually hydration of the ethers. For example, if I take this ROR, react with dilute H2SO4, it will give rise to ROH, two molecules of ROH. Actual molecule that is reacting here is water in presence of H2SO4. So, for example, if you take this diethyl ether, C2H5O, C2H5, that will react with water in presence of sulfuric acid to give rise to two molecules of ethanol. But when you take this concentrated H2SO4, concentrated H2SO4 will make the ethers to alcohol and alkyl hydrogen sulfate. For example, if I take this C2H5, OC2H5, react with one molecule of concentrated H2SO4, concentrated, then it will give rise to C2H5OH. One molecule of alcohol is produced from one alkyl group. Then the second one is actually converted to C2H5O, S double bond O, OH. This is called ethyl hydrogen sulfate, alkyl hydrogen sulfate. Then the next reaction is with PCl5. PCl5 will cleave both the carbon oxygen bonds and hence we will get the alkyl halides. Alkyl halides are formed. Both the carbon oxygen bonds are cleaved by the PCl5. That's why we will get this alkyl halides. Say for example, if you take this C2H5, OC2H5. Again same example. When you treat this with PCl5, we will get two molecules of C2H5Cl and this oxygen is taken up by the phosphorus to give rise to POCl3, phosphorus oxychloride. Then the third one is, so next one is action of air and light. When you expose ethers to air and light, then they will form the hydroperoxides. So these hydroperoxides are highly explosive in nature. That's why due to the formation of these explosive peroxides, you are not supposed to keep the ethers in the open or in the white transparent bottles because they will absorb the light as well as the air to give rise to these peroxides. Let me take this CH3, CH2O, CH2, CH3. This alpha carbon atom will be converted to peroxide. So it will give rise to, by the action of air and light, it will give rise to CH3, CH, OOH, O, CH2, CH3. Because of the presence of this peroxide bond, it is actually explosive in nature. Now to identify whether the ether is old stock containing the hydroperoxides or not, better we carry out one test. Take this old sample of ether, treat this with ferrous salts. This ferrous salt is converted to ferric salts. Ferric salt. By the action of this peroxide, this ferrous sulfate is converted to ferric salt. That is Fe plus 2 is oxidized to Fe plus 3. Then we use this property of the Fe plus 3 in the qualitative analysis that we are using. If it is treated with potassium thiocyanate, KCNS, potassium or ammonium thiocyanate, then it will give rise to the red blood color. Blood red color due to the formation of FeCNS thrice. If old sample contains the peroxide, then ferrous ions are oxidized to ferric oxides, ferric ions. This will react with KCNS, potassium thiocyanate or ammonium thiocyanate, to give rise to blood red color. Formation of the blood red color indicates the oxidation of Fe plus 2 to Fe plus 3, which in turn will indicate the peroxide. Same reaction can be used to eliminate the peroxides. All these peroxides can be reacted with excess of ferrous sulfate. Then peroxides are converted to corresponding ethers. Ferrous salts are converted to ferric salts, which can be removed by washing, or it can be treated with iodine, which is actually a potassium iodide. Iodine is produced. That iodine is extracted by using the sodium thiosulfate method. Anyhow, old samples of ethers contain these peroxides that can be either tested or eliminated by using this ferrous ferric oxidation. The next one is halogenation reaction. Halogenation. If you treat this with halogen, that is chlorine in presence of sunlight, we know that actually hydrogen atom of the carbon atoms are replaced by the chlorine atoms. This we have already studied in the first year hydrocarbons topic. But preferably alpha carbon atom first undergoes replacement. Suppose you take the CH3, CH2O, CH2, CH3. I will step by step I will write the reaction. If you treat with 1 molar amount of this chlorine, first one hydrogen atom in the alpha position is replaced to get this chloral derivative. Suppose you treat with 1 more molar amount in presence of sunlight. This actually follows the free radical mechanism. CHCl, CH3. By chance, if you treat with excess of chlorine in presence of sunlight, then all these hydrogen atoms are replaced by the chlorine atoms. CCl2, O, CCl2, CCl3. This is actually per chloro diethyl ether.